The revolution in physics sparked by pollen allergies and quantum mechanics. When we throw a ball, we can roughly predict where it will go. If we know its speed and direction, we can anticipate its future. This way of thinking is based on classical mechanics, developed by Isaac Newton. Classical mechanics is built on the belief that if we know the present precisely, we can predict the future. In other words, it explains the world through determinism. However, when we enter a world so small that we cannot see it, the story changes. The moment we shine light to observe a tiny particle like an electron, the light itself changes the particle's state. It is like trying to observe a leaf floating quietly on water. When we reach out to touch it, ripples form and its position is disturbed. Then are we truly seeing things as they are? The person who tried to answer this question was Werner Heisenberg. He discovered that in the microscopic world, we cannot know both position and momentum exactly at the same time. This is called the uncertainty principle. Simply put, the more precisely we try to know one, the less clearly we know the other. Interestingly, this discovery began not in a laboratory, but on a small island. Suffering from pollen allergies, Heisenberg retreated to Helgoland, where he came up with a new mathematical idea. If he had not had allergies, this revolutionary idea might have come later. Now, let us think again. If we take a photo of a flying ball, we know its position precisely, but it is difficult to know its speed. On the other hand, if we try to measure its speed, its position keeps changing. In the microscopic world, precision itself comes into conflict. This principle goes beyond a simple technical limitation and changes the very meaning of observation. In the past, we thought of the observer as someone who simply records results. But now we understand that the observer is a participant who affects the object at the very moment of observation. Because observation changes the outcome, we are no longer outside the world. Another fascinating idea is that before being observed, a particle does not exist in a single state, but in a superposition of many possibilities. Then, the moment we observe it, one of those possibilities becomes decided. It is like many paths existing at once, and the moment we take a step, only one path is chosen. In this way, quantum mechanics has transformed the certain world we once knew into a world of possibilities. Together with the theory of relativity by Albert Einstein, it has become one of the two pillars of modern physics. Even now, quantum mechanics is used in advanced fields such as quantum computers and cryptography. Perhaps future technologies will advance not by seeking certainty, but by understanding uncertainty. So let us think about it. Are we truly seeing the world as it is, or are we creating a new world each time we observe it?